Hello everyone, this is Mohammad. Welcome to my presentation titled Rheological Study of Warm Mix Asphalt in Arkansas. Warm mix asphalt technologies can reduce the mixing and compression temperatures of traditional hot mix asphalt. There are three major categories: foam-based, wax-based, and chemical additives-based technology. Potential benefits include less fuel consumption, better workplace environment, and less overhead cost. The objectives of this study were to evaluate the effect of WM additives on mixing and compression temperatures and ASTM AVTS parameters on 3 out of approved performance state binders. There are 3 binders used in this study: PG64-22, PG70-22, and PG76-22. The 3 additives were Susvit, Advera, and Redisec, and the dosages were chosen based on the past experiences and manufacturer's recommendation. Before testing, the binder has to be blended with the additives. The mixing protocol here was introduced by Dr. Hossain at 2013. It's the manual mixing protocol done at 160 degrees Celsius. There are 6 cycles, and each cycle consists of 9 minutes of heating and 1 minute of steering. ASTM AVTS parameters were defined by the following equation, where A is the y-axis intercept and VTS is the slope of the graph. VTS is known as viscosity temperature susceptibility of asphalt binder. A larger absolute VTS value represents more susceptibility to temperature change and vice versa. Penetration test has been performed following ASCII T49 specification. A total weight of 100 grams was applied for 5 seconds, and the penetration value was the average of 3 readings. The rotational viscosity tests were performed following ASCII T316, and mixing and compression temperatures were determined following ASCII T312 specifications. The test was performed from 135 to 180 degrees Celsius at a 15 degrees Celsius interval. The torque required to maintain a 20 rpm speed was converted to the viscosity of the sample by the instrument. It has been observed that without any additives, PG70-22 had highest penetration values, thus it is a softest binder, and PG76-22 had the lowest penetration values, thus it was very stiff binder. Overall, the binder put stiffer with higher susceptibility dosage, and binders became very soft when they were added to 6% of Advera. And binders' stiffness was found insensitive to Redisec dosages. The bottom 3 images showed that higher susceptibility dosage brought more reduction in the viscosity for PG70-22 binder, and Advera modification did not show any trend for any binder. Again, viscosity was found to be insensitive to the Redisec dosages for all the binders. From the left table, it has been observed that mostly WM modifications offered lower mixing and compression temperatures. These reductions were overall small for PG64-22 samples and noticeable for some modified PG70-22 and PG76-22 samples. Reduced mixing and compression temperatures for modified PG76-22 and some PG70-22 samples were still higher. On the right table, it has been observed that PG64-22, when modified with the 6% of Advera, had the least absolute VTS value, thus it's low susceptible to temperature change. Again, the same binder, when modified with the 1% of Susvit, had highest absolute VTS values, thus it is highly susceptible to temperature change. From this study, the optimum dosages of Susvit, Advera, and Redisec were 2%, 4%, and 0.75% by weight of the binder. At these dosages, samples from both PG64-22 and PG70-22 became stiffer, comparing to the respective unmodified samples. At optimum dosages, Susvit lowered the mixing temperatures for PG64-22 and PG70-22 by 6 and 16 degrees Celsius. Advera and Redisec lowered the mixing temperature by 1 and 9 degree and 5 and 14 degrees Celsius respectively. Similar kinds of reduction were observed for PG64-22 and PG70-22 in compression temperature determination. On the other hand, PG76 minus 22 samples, regardless of the modifications, yielded both mixing and compaction temperatures similar to traditional hot mix asphalt. At these dosage levels, modified PG64 minus 22 binder samples had temperature susceptibility similar or lower than unmodified sample. Other binder samples became more susceptible when they were modified by additives at their respective optimum dosage levels. It was assumed that long shelf life was responsible behind such results. Based on this study, 2% susceptibility was the best performing among all additives. I would like to thank Transit in Region 6, the Office of Research and Technology and Arkansas State University, and Ergon Asphalt and Emulsion and other suppliers for the test materials. If you have any question, please email me. Thank you.